Finish up module 2. We're going to go through module 2. So I know a lot of us probably want, chillax and thing, but yeah, please just bear with me. We're just going to do 3 and 4 and then we can call it a day, all right? I really want to go through 3 and 4 because it has some spice in it, all right? It has some spice. All right, now this part right here, so we did something similar to this in class, but not quite this one. Now this one says, so see there, this is another repeat. We did one from a closer year up, I think like 2013 or something like this. They say we have a sequence of positive terms, xn, and it is defined by xn plus 1 is xn squared plus a quarter, where x1 is a half. It says, show by mathematical induction xn is less than a half for all n. And I think Daniel did this question. Yeah, man, Daniel did a question like this on the board. So I'm going to save all the drawing now because we run out of page. All right, I save everything as PDF so I can share with all the working because I'm going to clear everything, but I save everything so I can send. All right. 2011, oh my word. What a time to be doing CAPE. It's a good thing they changed the syllabus 2012, right? All right, so this now it says xn plus 1, that's the first thing we need to write down. Xn plus 1, them tell we say this is equal to xn square plus a quarter. And then them tell we say where x1 is less than a half, or x1 is less than, x1 less than a half, x1 less than a half. So now them say show say xn less than a half. So number one now, from the question, x1 is less than a half. And so therefore n equal 1 is true. All right, because from the question, xn is less than a half. Therefore n equal 1 is true. Nothing really to do right there. So x2 now, it says, number 2, we're just going to write down, say, in step 2, xn is less than a half. I will assume that this is true. We assume true. Now, anytime you get a question like this now, for step 3, you always use the xn plus 1 what them give you. So we need to show that xn plus 1 is less than a half. That's what we're required to prove. So you can write it down, required to prove that xk plus 1 is less than a half. This is what we're required to prove, that this is less than a half. Since this is what we're required to prove now, all right, look back at this right here. So we're going to end up have xk plus 1. This is step 3. By the way, let me label this question. This is question 3A. This is the first part. All right. So,
Sir.
yeah.
For number 2 right there, so isn't it supposed to be like
K.
xk?
Yeah, xk. Sorry, yeah, xk. Thank you. So xk plus 1 now.
Sir, so why isn't it xk plus 1? Oh, wait, no.
Yeah, xk plus 1 here. Yeah. So xk plus 1 from this formula is going to be xk squared plus a quarter. Now what we're going to do in order to show them say xk plus 1 is less than a half is we're going to start from xk and tell them, say, remember, say xk is less than a half, and the man say, yeah, remember that. So we can tell them, say, all right, so watch this style now. So that means say xk squared is going to be less than a half square, which is a quarter. Then them say, yeah, I believe that. Then we can tell them, say, watch this style now. If we add a quarter to it, we're going to get x k square plus a quarter is going to be less than a quarter plus a quarter.
Oh, sir, I get that.
All right. And then
Yes.
now
Then
we
that
can tell them, say, this part is the xk plus 1. So now we can tell them, so watch the style now. So
that will
xk
be less
plus
than
1
half.
is
Yes.
less than half. That's how we tell them that part. All right. Now this is just 3 marks. All right. And now we need to put in our conclusion. Hence, n equal k plus 1 is true. And then now we can tell them, say, hence xn, then write it like this, hence xn is less than a half for all natural numbers. Nice. So that's that now, and we're good. So this never bad at all, never really bad. But this is the part now, but kind of nice. It says by considering xn plus 1 minus xn, show that xn is less than xn plus 1. All right? Show that xn is less than xn plus 1. To do this right here, so now, we need to consider xn plus 1 minus xn. Now look what we're going to do, guys. So xn plus 1 minus xn, that's going to be equal to x square n plus a quarter minus xn. Now, guys, look what I'm going to do. I'm going to rewrite this in another form. I'm going to write it as xn square minus xn plus a quarter. All right. Now look what I'm going to do now. I am going to factorize it and write it as, this can be seen as xn plus a half all square. You might wonder where me get this from. I'm going to show you why I did this. Because look at it. If you expand back the square, if you did have this xn plus a half, if you were to expand out this, expand out the square, you notice that you get first term square, which is xn square, plus twice the product of the two, which you get is 2 times xn times a half. Wait, this seems to be a minus. So change this to a minus here. Yeah, this gonna make it right now, because then this will be minus. And then now we have plus a half square, and that gonna give you the quarter. So it makes sense, don't? This makes sense?
Sorry, would you have to change the other thing to a minus 2? Xn plus half all squared.
Xn.
Below it, sir. Below it, sir.
Oh yeah, this is supposed to be a minus. Yeah, I was just showing that when we expand it, this is what we get, right?
Okay.
Yeah, so what I'm saying is this is what we're gonna do now. So you might wonder why. I'm gonna show you why. They said by considering it. So when we consider it, this is what it actually worked out to be. And so now this is extremely helpful. Why is it helpful now? Because guys, look at this. Remember that xn is what? Xn is less than a half, right? Right? Xn is less than a half. So if we subtract a half from both sides, we're going to get xn minus a half. If we subtract a half from both sides, that is less than 0, don't it? Less than 0 means it's negative, meaning that it is negative, meaning that we're getting a negative number. But when you square a negative number, what happens? When we square both sides, what gonna happen?
You should have 0.
When we square both sides, no, this is the trick now, this is the trick. Guys, when you square both sides, you're going to change the sign from less than to greater than. That makes sense?
Yes, sir.
Yes, sir.
So we're going to get xn minus a half all square is greater than 0. But then now you can tell them about xn minus a half square, that was xn plus 1. So now that is then xn plus 1 minus xn, and this is greater than 0. So now we can bring over the xn to tell them xn plus 1 is greater than xn. And so this is how we end up tell them, say, xn is less than xn plus 1. Yeah, man. So this wasn't too bad, but given the thing them what them asked before, this wicked. Right? Like this wicked, like given the question them before, then pepper away with a factorial integration, then pepper away with a integration where we have to use, what was that we had to use? We had to use trig substitution, then they peppering us with complete in the square. So then pepper this year, man. This year was nice. And you think of that alone, pre this now, we're gonna have to do binomial expansion with this. They hardly ever put partial fractions to expand with binomial expansion, and what a year to put it on. Guys, imagine if we're doing paper 2 in 2011. This nice, though. I mean, it's tough, like it really tough. 2011 was really tough. All right, this was all right. I'm really hoping that no more year, at least I'm hoping that this year won't be like this, but if a question repeat from this year, we're well prepared for it. All right, so let's look at this there. The next part says find the constants a and b, for which this constant is a over 1 minus x plus b over 1 minus 2x. So we have 2 minus 3x over, what was that again? 1 minus x times 1 minus 2x.
So for that, would you have to cross multiply?
Cross multiply, what we want cross multiply? We're gonna use
In like saying a would be multiplied by 1
cross
minus
multiply.
2x.
Oh yeah. Partial fraction, yeah.
Terms of that, yeah.
Yeah, that's we can cross multiply, won't write it as one fraction. Meaning,
Yes.
so we bring up the 1 minus 2x, so it's a times 1 minus 2x, yeah? Then now plus b times 1 minus x. You're definitely right.
Yes, sir. Over the denominator.
Right. Over the denominator. And then, of course, we can just, guys, we can't bother put over the denominator because we're skipping steps. We just equate it to the numerator here. 2 minus 3x. So now what we can do is, if we want to make it short, you can let x equal 1. If we make x equal 1, on the left-hand side, we're going to get 2 minus 3
That's minus 1.
equal, this is what now?
2 minus 3 is minus 1.
2 minus 3, yes, so this side is minus 1. And what's going to be on there right now?
A times 1 minus 2.
And 1 minus 2 is minus 1, so that's minus a, right?
Yeah, and b would be 0.
So a equal 1, and b part would cancel.
Yeah.
All right,
So
nice.
1 a.
The a equal 1. Then we can just make, right here, so this look like half. Let me see, 2 times half is 1. Yeah, let x equal half now. Let x equal half. If we plug in x as half now, continuing over here, so gonna be what? 2 minus 3 times half is 3 over 2. 2 minus 3 over 2 is 1 over 2, right?
Half again, yeah.
And then this gonna cancel. Then 1 minus half is half. So we're gonna get half of b. Then half cancel. So b is 1 to do.
Yes, sir.
So b equal 1. That never bad. So that was what they want to find a and b. That not bad. You can tell them, say it's just 1 over 1 minus x plus, this is now 1 over 1 minus 2x. All right, this never bad at all. Now let's see. That's all I wanted. Yeah, find the constants a and b. Obtain the first four non-zero terms of the expansion of these using power series. Now, guys, remember what I said, when the power is negative, which one of the binomial expansions we use?
Extension. Wait.
The extension. Yes, you're right, extension. All right, always remember when the power is negative, we use the extension formula. We use this one, the 1 plus x to the n equal the 1 plus nx. Yeah. All right, nice. So guys, please remember this is the one we use anytime the power is negative or it is a fraction, you use this formula. Please remember, anytime it is a whole number, if let's say it was a cube, then you'd have had to use the other formula for binomial expansion. Please bear that in mind. So in this case now, what we're gonna get is, we can rewrite this now as we're actually just expanding. 1 over 1 minus x can be written as 1 minus x. Let's write out the whole thing, just so them see so we know where to do. We're gonna tell them say 2 minus 3x over 1 minus x times 1 minus 2x. We can pretty it up now and tell them say, we know say this is equal to 1 over 1 minus x. Then we have plus 1 over 1 minus 2x. Then what we're going to tell them is now 1 over 1 minus x is the same as 1 minus x to the negative 1. That's what we're going to tell them. This is 1 minus x to the minus 1. All right, we'll call it this. So now we're going to use the extension formula. We know that it is 1 plus n times x, and in this case it's negative 1. So it's negative 1 times x, x in this case is negative x, plus it's then n, which is negative 1 times n minus 1. So that is going to be negative 1 minus 1, that's negative 2 times x squared over, and it's actually negative x being squared. So you have to be very careful, negative x being squared, and we divide it by 2 factorial, which is 2. Did they want up to x cubed or just up to x squared? Obtain the first 4. Guys, when they say first 4, we're gonna have to go up to x cubed. So this is 1, 2, 3 term. So going up to x cubed now, this is going to be n times n minus 1 times n minus 2, which is negative 3, times minus x cubed, and this is being divided by 3 factorial, and 3 factorial is 6. So finally, what we end up getting is 1 over 1 minus x. The part there, I want to simplify now just to be 1. This look like plus x. We notice, guys, look at this. The minus and the minus become plus. 2 over 2 gone. So end up get plus x squared. Then negative, 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 and negative. That gonna be positive. Then the 6 over 6 gone. So that is just plus x cubed. That don't work out bad at all. So that's what we get for 1 over 1 minus x. So now we need the expansions for 1 over 1 minus 2x. So we can tell them, say, 1 over 1 minus 2x. We can tell them, say, this is, of course, going to be equal to 1 minus 2x. And this is being raised to the minus 1. And so now, since this is being raised to the minus 1, it's going to be 1 plus nx, n is negative 1, so it's negative 1, times x, x in this case is negative 2x, plus n times n minus 1, so that's now negative 1, times n minus 1, it's negative 2, times x squared, in this case it is negative 2x being squared. I will divide that by 2, plus, we then have n, negative 1, times n minus 1, negative 2, times n minus 2, negative 3, multiplied by 2x being cubed, or divide that by 3 factorial of 6. So this going to simplify now to be, this going to be 1 minus or minus cube plus, so get plus 2x. Then this part going to now be minus or minus is plus 2, cancel the 2, minus 2x squared, that is 4x squared. 1 plus 2x plus 4x squared. This now is minus 2 here, so all of this become positive. The 6 cancel out the 6. So we get 2 cube is 8. So we get plus 8x cube. All right. So around here, so we end up get 1 plus x squared plus x cube. This one is 1 plus 2x plus 4x squared plus 8x cube. But remember, this is what we, oh, that's all they wanted? Obtain the first 4 for this expansion and this expansion. Oh, they didn't ask us to find the whole thing together. They just want them separately. So we don't even need to come.
You want the whole thing, we just add them, right?
Yeah, just add them, yeah. So them don't even want this. So at least that's not bad. So now them just say, all right, so we're done. Really done. All right, so we're done. This would be for this part. That would be for this part. Because I was like, whoa, if them did ask for the whole of this, that would have put it for work, but that's not bad. The next part now them ask is them say state the range of values of x for which the series expansion is valid. Now always remember that the expansion is always valid. I'm going back to the formula. The formula is only valid when the modulus of x is less than 1. In that case, we're saying that x is between 1 and minus 1. So in a case like this now, from this question, from this one right here, this one would be valid between 1 and minus 1. So you have minus x, the modulus of minus x, which is x. In a case like this, it's valid when x is less than 1 but bigger than negative 1. But around here, so now it's going to be a case where it is valid when 2x is between 1 and minus 1. So in a case like this now, since this is where this one is valid, this part would simplify just to be it is valid when x is between 1/2 and negative 1/2. So combining the two solutions then, this part valid here, so this part valid here, so hence a series expansion now, so we can tell them a series expansion for, hence a series expansion for the expression 2 minus 3x over 1 minus x times 1 minus 2x. That's only going to be valid when x is between 1/2 and minus 1/2. That's the only time it will be valid. So this will be valid when, in this case, when x is less than 1/2 but bigger than minus 1/2. That never bad at all. So that's when this one will be valid.
How you know when it's valid again?
All right, so go back to the formula right here. The formula, as I say, it's always valid for when whichever number right here, the modulus of this number is going to be between 1 and minus 1. That's when it is valid. The expansion is valid when whatever number right here is between 1 and minus 1. So in this case, if the number right here, as we can see, is, in this case, it is minus x. So we're really saying when the modulus of minus x is between 1 and minus 1. But if you multiply through by minus 1, you're still going to get x is between 1 and minus 1. In this case now we have where 2x is between 1 and minus 1. But since in that case where 2x is between 1 and minus 1, we can divide through by 2 to get x is between a half and minus half. Now, when you combine the two of them now, if you combine this solution region with this solution region, then you just go with the smaller solution region. So that's why it's valid right here. That would be the answer. Nothing much to this one, but that's not bad. All right, so that would be this right here, which is part A. Now part B says find the coefficient of x to the n in part 3 above. In part 3A, find the coefficient of x to the n. Now, to find the coefficient of x to the n, you do it by observation. All right? So even though we didn't find the actual expansion of it, it's good now we keep on writing down what would happen. So we're going to write down what would happen now if we actually add them. If you were to add them, look what you'd end up get. If you were to add them, I'm just going to add them to tell them that 2 minus blah, 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 it would end up be equal to 2 minus 3x over 1 minus x times 1 minus 2x. We're going to finally tell them, say, this can be equal to 2 plus, this is 2 plus, you want to know where we get the 2 from? I got the 2 from right here, so 1, this one here, so, plus this one right here, so, give me 2. Then the x right here, so, plus the 2x right here, so gonna give me 3x. Then I'm gonna observe the x squared them now. The x squared, 4x squared, and the x squared gonna give me 5x squared. So this is now 2 plus 3x plus 5x squared. Now observing the pattern now, add 1 to it, add 2 to it. Let's see what happened now. Look like add 4 to it. This gonna be 4x squared. Oh, add that already. The x cubed now, plus the x cubed, that's 9x cubed. So this would have been 9x cubed. Guys, I already see the pattern, right? Look at the pattern. Add 1 to it, add 2 to it, add 4 to it. What would have been the next one here? Now x to the x, 17x to the 4, see? This makes sense? That would have been the next one, though. Add 8 to it now, then add 16 to it, which have then been 33, x to the 5th. I will continue. This makes sense?
Yes, sir.
So now we're just going to decipher now and tell them what would have been like an expression or the coefficient in x to the n. So let's decipher x to the n now. We're going to decipher a formula for it. All right? Now, as you can see, we're following the sequence. This is following the sequence 2, 3, 5. We just want to find an expression for the nth term, and that's going to be the coefficient of x to the n. 2, 3, 5, 9, 17, 33. Let's decipher what this is now. All right. So 2, as I say, 1, 2, 4, this. All right, this would have been next is 32, that's 65. I see it, you know, it's 2 to the n. This is 2 to the n, but something missing. Let me see. 2 to the n gonna give you the 32. This is 1 plus 2 to the n. Let's see. When n is 0, when n is 0, 2 to the 0 is 1. No, we're supposed to get 2. When n is 0, oh, you get
Yes,
1
sir.
plus 1
Yes,
is
sir.
2. Yeah,
Yes,
this
sir.
right.
Correct.
Yeah, man, nice. Yeah, man. Because when n is 1 now, so this is the coefficient now. So hence, coefficient of x to the n, hence coefficient of x to the n is 1 plus 2 to the n. So that's this one right here, coefficient of x to the n. That's it. We don't have nothing to worry about. Nice. 1 plus 2 to the n. So we can actually just tell him, so this nice. All right. Just to look on a little sequence and see what the pattern. And then nothing to stress we out. All right. Yeah, man. That's that right there. Now this part now, it says now the sum Sn of the first n terms in a sequence is given by Sn is n times 3n minus 4. And they say, watch the style. Show that the series is an arithmetic progression with a common difference of 4. So Sn is 3n times 3n minus 4.
There's a common difference of 6.
Yeah, so we need to show it have a common difference of 6.
So if we
Sn,
So we just find like the first couple terms and then subtract like the second from the
very good.
first.
That's all. But you need to find the first 3. You can't just find 2, because if you find 2,
Well, no, not to the work out like at least 4 for them to make sure
yes.
it's the same thing.
Yeah, make sure I same thing. So first, we'll plug in n as well. So yeah, man, we're boy it up. I'm happy to hear that. So we'll plug in the 1. We get 1 times 3 minus 4, which is negative 1. So S1 is negative 1. So we know, so the first term A is minus 1. All right. Then we'll plug in n as 2, which is S2. S2 now we know, so is the first term plus the second term. So the first term, which is A, T1 is A plus T2, that got equal to, we'll plug in 2. 2 times, this is 6 minus 4. Wait, 3 times 2 is 6.
2
6.
times 2.
2 times 2, yeah. And 2 times 2, we know that it is 4. So that is S2. But remember, say T1 is negative 1. So this is negative 1 plus T2. And that equal to 4. So we can just now bring over the minus 1 now to get T2. The second term is 5. Now we just need to find one more term, T3. So we're going to plug in n as 3. S3 now is equal to, plug in n as 3. We'll get 3 times 3 is 9. 9 minus 4 is 5.
5
Yeah, so 3 times
times
5 is
3 is
15.
15.
But 15 is going to be equal to the first term, negative 1, plus the second term of 5, plus the third term, T3. So we can say this is now minus 1 plus 5 is 4. Bring over the 4, that is 15 minus 4
11.
is 11. So T3 is 11. So just to write out it as a list now, as an AP, write out the AP now. All we're going to end up write out are the terms. T1 is minus 1. Next term is 5. Next term is 11. Now to show so it's a common difference, see the common difference, which is equal to T3 minus T2. That is 11 minus 5, which will end up get 6. But guys, you can't just tell them say T3 minus T2, or hence common difference is 6. You have to show say constant at somewhere else and show them say which is also the same as T2 minus T1, which is 5 minus minus 1. So this never bad at all. Why did I think this one would have been challenging? Nice, that's 6. So that's how we show that it is a common difference. All right, so hence,
Wait, sir, the formula is for the sum.
yes, the formula is just for the sum.
Oh, that would be the only part you have to pay attention to.
Yeah, we just have to pay attention to is not the nth term formula them give us, but rather they give us the sum formula. So that was the only little trick right there. So we can tell them hence the common difference is 6. All right. That never bad at all, man. That never bad at all. So nice. So can tell him, yeah man, common difference is 6. All right? And that is question 3 right there. Question 4. Now this one right here give GP. So notice that area really spicy, you know, it give AP, it give GP, proof by induction, it give the expansion where hardly ever come. Then they give GP, they're testing everything this year, 2011 bad man, 2011 bad. So it tells us now, a geometric progression with first term A and a common ratio R is such that the sum of the first 3 terms is 26 over 3 and their product is 8. So if the sum of the first 3 terms is 26 over 3, remember a GP, the first term is A, first term is A plus, the second term is A times R, and the third term is AR squared. And then them tell us that this have a sum of 26 over 3. All right. And then them tell us that the product of the first 3 term is 8. So what them telling us is that A times A minus R times AR cube, they're telling us that that equals to 8. So now AR square, why I put cube? AR square. All right, so now working out the product, I say A times A is A cube, and then R times R is R cube equal to 8. So if I were to make A the subject here, I notice that A cube would be R cube of, well, 8 over R cube, 8 over R cube. But guys, look how I'm going to rewrite this. This number 8 right here, I can put as 2 being cubed. So I can cube root both sides. When I cube root both sides, that would then tell me, say, A is equal to 2 over R when I cube both sides. When you get A is 2 over R now, what do they want? They want us to show that R plus 1 over R is 13 over 3. So now that A is 2 over R, we can plug A as 2 over R into any one of the equation. I'm going to use the first one since this one looks simpler. I plug it in this one, I'm going to get A as 2 over R plus A times R, 2 over R times R, that's now just plus 2, plus A times R square, that's gonna give me this times R square, put 2R, yeah, that's gonna be 2R times 2R, and that's equal to 26 over 3, and then we get 13 over 3. So now, dun dun dun, we need to factor out a 2, but let me see. This is over 1 over 1. First thing I'm going to do is put everything as a common LCM before I can, before I just, well, yeah, we can just divide through by 2, yeah. Let's divide through by 2. We don't need to put nothing as nothing there. Let's divide through by 2. You're going to get 1 over R plus 1 plus R equal 13 over 3. That never 3 bad. That can pass. That never too bad. All right, so prove it. So we can just put nice. All right, so do that, we can just put nice. All right, so that's what we get right there. It says now, hence find the value of R. Now, once you end up reach here, so it's easy to find R, we're just gonna solve this equation. We can multiply through by, I'm going to multiply through by 3R because I want to get rid of any kind of fraction-ish. Multiply through by 3R, we're going to get 3R over R is 3 plus 3R times 1 is 3R. 3R times R is 3R squared. 3R squared. That's going to be equal to 13 times 3r, that's 39r. So now we end up with a quadratic, 3r squared. Bring over the 39 over here. Bring over the 39 over here. 3r minus 39 is minus 36. Is that right? Plus 3.
Wait, how you get 39?
I times through by, wait, oh, I don't get 39. Where I get when I
You
times
get
through?
13R.
13r, thank you. 13r, giving it away. 13r, nice. So now we just get 3r squared. Bring over the 13r. So 3r minus 13r, that's minus 10r. And then now we have plus 3. And then now we can factor. Oh, it worked out well easy to factorize. Thank God. So now that it worked out really easy to factorize, it's going to be 3r and r. It says signs are the same, but both of them positive. So no, this is the 3 and this is the 1. Both of them, it's the same sign, both of them negative. So r minus and minus. So this one is telling us that r equal 3 or r equal 1. Now, r equal 3 or r equal 3 minus r equals 0. 3r minus 1 equals 0. Bring over the 1, or r equal 1 over 3. So r equal 3 or r equal 1 over 3. Now this one can't happen. This one is not valid. So we can write NV not valid. It's not valid because then they tell we say at the start of the question r have to be between 0 and 1. It can't be bigger than 1. So in a case like this, r just equal 1 over 3. That's the answer. And then we already know A. A is 2 over R. So we can quickly finish that off and tell them, say A is 2 over 1 over 3. 2 divided by 1 over 3. I want to flip it. 2 divided by 1 over 3 is what? That is 2 divided by 1 over 3. 2 times. Wait, what am I
I
doing?
think that's 6.
That's 6.
That's 6? That's 6. All right. I was just about to write 3 over 2. That's 6. Thank you. That's 6. Nice. So now we get the value for A. Now they want sum to infinity. It ended up being easier than we thought. Now they want sum to infinity. Now they want sum to infinity. Sum to infinity is A, which is 6 over 1 minus R. 1 minus 1 over 3. That's the formula for sum to infinity. A over 1 minus R. So this is now just 6 over 1 minus 1 over 3 is 2 over 3. So we can multiply. This is, I'm going to flip it. 6 divided by 2 over 3, which is multiplied by 3 over 2. So 3 times 6 is 18. 18 over 2, that's 9. We get 9?
Yes, sir.
That's the sum to infinity. 9. All right, so this never bad at all. That's just 9. All right. Now, this one right here, so now it says expand 2 over e to the x plus e to the minus x. Now, you see this one now? 2 over e to the x plus e to the minus x. Okay. And it wants it in ascending powers of x as far as up to x to the 4. Now, this right here, so now you can use any one of the power series you want. But first thing, we need to get it in a form where it, all right. So guys, you can, if you want to use McLaren, you can. If you want to use Taylor, you can. If you want to put it in a form where you can use binomial expansion, you can. It did not tell you which one to use. Anyone is valid. So let me tell you, anyone is valid. The only issue is that you have to just remember that you have to put it up to the 4th term. So anyone is valid. So it's call it f of x, and I want you to help me to differentiate this. I really don't like to differentiate these quotients with e, This is really 2 times e to the x plus e to the minus x to the minus 1. Help me to differentiate this now. What would be f prime? I need to differentiate 4 times. What's f prime?
We're using the product rule.
Well, not really product rule. We'll write it this way. Really chain rule we're going to use.
Oh, chain rule. Oh, all right. So minus 2. Right back everything in the bracket. Raise to the power minus 2.
Raise to the power of minus 2. Now multiply.
Times
Yeah.
1
Times,
e to the x.
this is just e to the x, yeah.
Minus e to the x.
Minus e to the x. Minus e to the minus x. Nice. So now, of course, plug in f of 0 for me. We're going to need f of 0. What's f of 0? Plug in 0, 0. 0. This is what? 1. E to the 0 is 1. E to the minus 0 is 1. 1 to the minus 1. 1 to the minus 1 is 1. 1 times 2 is 2. Is that 2? We all getting 2?
I am getting 1.
You get 1?
Yes, sir.
All right, you get 1. Who get 1 there? E to the 0. We take out calculator. I want to say that there.
Yes, sir.
Just want to check it when I put in the 2 over e to the 0 e to the 0, and that is plus, oh yeah, for true, it's gonna be 1, because 1 plus 1 are cancelled. Yeah, e to the 0, that's 1 plus 1. Yeah, it makes sense, it makes sense. Yeah, I don't need to see it no more. Yeah, it makes sense, it's 1. All right, and then when we put in 0 in this one, what we're gonna get now? So I don't like differentiate with e, whole heap of work. Put in this one now. 0. This is 1 plus 1. 1 plus 1 is 2. What? This is 2 to the minus 2. What's 2 to the minus 2? 2 to the minus 2 is 1 over 2 squared. That's 1 over 4. 1 over 4 times minus 2 is minus a half.
I get
So
0, sir.
You get 0, so it's minus
I
a
think
half.
I think the outside, the e to the 0 minus e to the 0. I think that when you multiply it, everything
This,
will be 0.
This, yeah, get 0. Nice. At least that smoothed it out for us. Now we need f double prime. F double prime of x. Now we're gonna have to use product rule to differentiate this. All right. So we're gonna differentiate. You can keep the first minus 2 times e to the x plus e to the minus x to the negative 3 now. Keep the first times the derivative of the second. We differentiate this, what we get now? We get e to the x. Is this now plus, right? Plus e to
Yes,
the
sir,
minus
plus.
x, yeah. Then now we have plus, keep the second, which is this. No, we differentiate the, wait.
Yes, sir. Keep the second differentiator first. We didn't differentiate it 2 times whatever. So you can write about the second one and then differentiate.
Oh, let me put that 2 here. So keep the first one, differentiate the second, plus now keep the second one, e to the x minus e to the minus x. They'll multiply it by the derivative of the first,
Minus,
which is
no,
going to
plus
be
4.
It's gonna be plus 4. So we can just put the 4 here. So drop it on right here. So sucker, nice. Then we
Write back everything inside of the bracket.
e to the x plus e to the minus x
Raise to the negative 3.
raised to the negative 3.
Times the difference loss inside of the bracket.
which is the e to the
Same
x.
thing as
Yeah, it's the same as this right here. E to the x minus e to the minus x. My gosh. Holy power. Code us pretty it up now. Since we know we're gonna have to differentiate a couple more time, we're gonna have to differentiate 2 more time. Right? We're gonna have to differentiate 2 more time. Because this is gonna be here. We're gonna have to differentiate 2 more times. So might as well pretty it up. Cleaning it up, I can say that this right here, e to the x plus this, you're gonna cancel out one of them here, though.
yes, sir.
So we can
Nine.
actually say that it is minus 2 times, this is just now e to the x plus e to the minus x, and that's to the minus 1 now.
1 power.
And this is now plus over here, so now this gonna be square. So we can just write it as plus 4 times in bracket e to the x minus e to the minus x raised to the second power, and that is being multiplied by e to the x plus e to the minus x, and that's being raised to the negative third power. No need to plug in 0. Plug in 0 for me now, real quick. And plug in 0, what we get?
Coming, sir.
All right, on 0, that's 1 plus 1 is 2. Too much work that. Yeah, let me wait.
-1, sir.
Minus 1. Imagine, guys, math's beautiful. Now imagine you do all of this. Just forget when you plug in 0, you get -1. Math's so pretty, man. Go find with third derivative now. F prime prime prime, that's equal to, we carry down the power 2, subtract 1 from the power, e to the x plus e to the minus x. Subtract 1 from the power, this is now minus 2 times the derivative in the bracket, which is e to the x minus now e to the minus x. Then we have plus over here, so we're going to differentiate this as a product now. So we can keep the first. We can keep the first, which is 4 times e to the x minus e to the minus x, that is being squared. Keep the first, differentiate the second. Or differentiate the second, we're going to get -3, carry down the power, subtract 1 from the power, that's now to the -4. They'll multiply it by the derivative inside of the bracket, which is e to the x minus e to the minus x. They will put plus, keep the second now, which is this part, multiplied by the derivative. So which one would they keep first? Keep the first, differentiate the second, plus keep the second now, then differentiate the first. So now we're going to differentiate this part now. Differentiating this part would
8.
so get 8 here.
Inside the bracket.
E to the x minus e to the minus x. Subtract 1 from the power, that's 1, times the derivative in the bracket, which is just e to the x plus e to the minus x, yeah? And then we'll put back the second. The second was this to the -3. Now look at this, since we have this right here, so, and it's being times by this, 1 to the 1 power times to the -3, we can just put to the -2 though. That makes sense?
question
I
there,
wasn't
please.
looking, but I guess so, sir. I start putting in the e to the 0 now. It took a while.
Yeah. So put in the 0 then for me now, because yeah, this gonna take a while. All right, so we're gonna clean it up in the next line and then we're done. One more derivative, then we're done. Now this will give us f triple prime of 0. Okay, all plug. You finished, Kevin?
I think I probably reached the limit of how much things I can.
Oh, that's why. Let's clean it up now so it helps you to probably plug in the 0. Just to pretty it up. F prime, prime, prime. We're going to pretty it up. This part, this. All right, that is just.
Hold on, sir. I have everything up to the +8, so I'm gonna work out that first part and math error.
Okay.
All right, you can do it, sir.
All right. Let's pretty it up now. We can put back the 2. This was the e to the x. This was plus e to the minus x to the minus 2. This was times e to the x minus e to the minus x. Over this part now we can clearly pretty up. This part definitely have some prettying up to do. This part square times this. The square, this is a minus here and this is to the 1. So this part, this times this is cube. So we can put 3 times 4 is minus 12. So this we can put minus 12 e to the x minus e to the minus x, and that's being cubed. And that's being multiplied by, right here, so is, this is now to the minus 4, e to the x plus e to the minus x to the 4. Then go back around here, so now this part now, the last part here, this can't simplify this part, so just put back that plus 8 times the minus part. Well, we can simplify it. You can, you have this. You can actually simplify because 2 of this, you have 8 of this, and 2 of this. You can just put it as 10 of that. So you can actually simplify that now and write it as 10 of that. So what you get Kevin, we'll put in that f triple prime.
All right, that was 10.
And while they do that, we'll go and work on the 4th derivative. So then now we can just put in the answer after. All right, so keep on differentiating this now. We keep the first 10 times e to the x, e to the minus x squared. Keep the first. We then differentiate the second, which is going to give us e to the x plus e to the minus x as the derivative of the second, plus keep the second now. Keep the second, which is e to the x minus e to the minus x times the derivative of the first. Derivative of the first, we can put back the 10 plus put back the 10. Differentiate the first, we carry down the power. 2 times 10 is 20. So we can put 20 here. Subtract 1 from the power. This is now e to the x plus e to the minus x. Subtract 1 from the power. Should have been minus here. Let me see what we did. Keep the first, keep this
Sir, I
one.
get 0.
You get 0?
Yes, sir.
All right, so that's 0. Nice. All right, now here, so now we keep the first, differentiate the second, plus keep the second now, differentiate the first, this becomes minus 3. Minus 3. Minus 2 times it should have been negative 20. All right. Let's see if I differentiate it properly again. Keep the first, differentiate the second, plus keep the second, differentiate the first. So do that part good now. Now this part now, so almost done now. Then now we have minus, we're gonna have to differentiate another product. So we can have minus 12 times, think of this as one term. So minus, keep the first, the minus 12, e to the x minus e to the minus x, and that's being to the third power. Keep the first times the derivative of the second. Bring down the 4. Bring down the 4, that would become 48. Keep the first, differentiate the second. That's going to become e to the x plus e to the minus x. This is raised to the third power multiplied by the derivative inside the bracket of e to the x minus e to the minus x. Then now plus, keep the second, which is the e to the x, put the second way out here, e to the x plus e to the minus x multiplied by the derivative of the first. The derivative of the first is, carry down the 3, that's minus 36, and change this to minus 36. Subtract 1 from the power, that's e to the x minus e to the minus x. That's going to be square multiplied by the derivative inside the bracket is this. So we can change this 4 to 5. All right, so done now, Kevin. Just plug in the 0 in this one now.
All right, sir. I might have to break it up into 2 parts.
Yeah, no problem.
So I'll work on the 10 and 20 part first.
Yeah, no problem. All right.
How would the people in a 2011 could I do 6 so?
Repeat.
So I don't know what them people in a 2011 could I do 6
Yeah, 2011. Why? It wasn't the year to the Cape, man. Wasn't the year to the Cape. Cape Mats, like, I don't know. As I say, I don't know where them do 6C, but them clearly do 6C something, man. Because from question 2, question 3, now question 4. But the good thing is module 3 was well easy this year. So I guess what they were saying is start with module 3. Right, Mario 3 did well easy, so I guess them, I don't know what them trying to say because it's still not balanced. Don't know where them to keep this year. In the meantime, we can start write down f of x. If we want to write it down below here, now we know f of x can be equal to f of 0. We found f of 0 to be 1 plus x. F prime of 0, we get f prime of 0 is 0. So it's 0, 1 plus 0 times x plus x squared. Now it's minus 1 x squared over 2. Then it's going to be plus x cubed, which is 0x cubed over 3 factorial. 0x cubed.
Sir, I get 5.
You get 5. Nice. Then now plus 5x to the 4 over 4 factorial, which is 24. Yeah, man. This look about nice. So we can tell them, say, all of that work out now to just be 1 minus x squared over 2 plus 5x to the 4 over 24. Right? As Roshan said, we don't know where. We don't know what happened in 2011. We don't know why people do this. But, you know, just in case one of them questionnaire repeats, we know how to tackle them. All right? One of them. Because we definitely know so keep and never so hard again. But just in case them take off one of them questionnaire. All right? The last part, we can do this in 10 minutes. Let's wrap up in 10 minutes. This is well easy. F of r is 1 over r plus 1. Find f of r minus f of r plus 1. So writing that down, f of r is equal to 1 over r times r plus 1. And they want us to find f of r minus f of r plus 1. So f of r minus f of r plus 1, that's going to be equal to, replace r with r plus 1, that's going to be 1 over r times r plus 1. It's r plus f of r minus f of r plus 1, or f of r plus 1 minus f of r. Okay, f of r minus f of r plus 1. That's 1 over r plus 1 over r times r plus 1 minus 1 over r plus 1 times r plus 2. All right, this one is a little bit different because now we're going to have to find LCM, but it's going to be with 3 terms. That's a little bit odd. LCM going to be r times r plus 1 times r plus 2. That's really odd with 3. Well, let's see if it's still going to be a method of difference. This into this would leave the r plus 2. 1 times r plus 2 is r plus 2. Minus this into this, just leave the r. And so r plus 2 minus r, that just leave 2. So it's 2 over r times r plus 1 times r plus 2. All right, that's not bad so far. That's not bad. So we'll get with 3 marks so far. That would be f of r minus f of r plus 1. All right, so we'll do that first part so far. That's part 1. All right, 2 minutes that take that not bad. 2 minutes for 3 marks. Then now they say hence or otherwise find the sum of 3 over r times r plus 1. So now we have Sn, which is equal to the sum from r equal 1 to n of 3 over r times r plus 1 times r plus 2. Now you see that 3 there? We don't want to work with no 3. We need a 2 right there. So what we're going to do is we can multiply by 2 over 2. And then this 2, we can switch the 2 right here, so with the 3 here, so, and put the 3 here, so, and put the 2 right here, so. Now this part, we know what this is. We know that that part now, it's gonna just be 3 over 2 now times the sum from 1 to n of f of r minus f of r plus 1. I already know the sum of f of r. So we need the sum of f of r minus f of r plus 1. That is now 3 over 2 times. We can evaluate the sum them now. Let's look at the first part when you have f of r. F of r was 1 over r times r plus 1. Plugging in r as 1, you'd have get 1 times 1 plus 1 is 2. That's 1 over 2. It should have been 1 over 2 here. Plugging in when r is 2, it would have been 1 over 2 times 2 plus 1. 2 plus 1 is 3. So that would have been 1 over 6. We'll plug in 2 here, so 2 times 3. Plug in r as 3 now, it's going to be 3 times 4, which is 12. So we're going to get plus 1 over 12. I'm going to keep on do that till we plug in r as n. I'm going to get 1 over n times n plus 1. Then now we'll close up that bracket. Now we're subtracting on this side now r plus 1, f of r plus 1. We're plugging in 1 in here. So now first, when it is 1, it is 1 plus 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. So this one start with 1 over 6. So the next one going to be 1 over 12. And it going to continue till we plug it down to the last term, which is 1 over n plus 1 times n plus 2. So this is not bad at all. N plus 1 times n plus 2. Because now we can start see which one cancel out. And then I put the closing bracket. Now we can start see which one cancel out. The 1 over 6 gone. 1 over 12 gone. Every other number gone. This gone with the number before it. So get left back with the sum is now 3 over 2 times in bracket, that is a half minus, this is now a half minus 1 over n plus 1 times n plus 2. Then I can bet to the next thing them ask is deduce the sum to infinity. So this never bad at all, right? This is another easy one, 4 marks. We'll leave it here, so that's Sn. Then now they want to find, deduce Sn Telemann, then hence find sum to infinity. Find sum to infinity now. We just replace n with infinity, so can even just squinch it on somewhere right here. So you can tell them, say S infinity, the last part, would be equal to, this is now 3 over 2 times, in bracket, a half minus, when you plug n as infinity, this becomes 0. That becomes minus 0. Then 3 over 2 times half is 3 over 4. That's the sum to infinity. We cool with this question?
Yes, sir.